Hello students, welcome again to my channel DNA.1 to Education. Today we are going to talk and discuss in mathematics topics. The topic is factor. In this video we are going to discuss what is factor, position factor, 2 and 3-dimensional factor, operation on factor, how to draw factors, Euclidean geometry, factor projection, and orthogonal factor, and so many things. Cambridge Test and International Test Preparation Series. Our topic is factor. Let's start studying. What is factor in math? A factor is an object that has both a magnitude and a direction. Geometrically, we can picture a factor as a directed line segment whose length is the magnitude of the factor and width an arrow indicating the direction. The direction of the factor is from its tail to its head. Look at the diagram, and the blue arrow is the direction, upright, and the green color is magnitude or length of factor. What is position factor? A factor that starts from the origin O is called a position factor. Look at the xy axis. Point A has the position factor A and point B has the position factor B. The coordinate of A is 3, 8. So factor OA is A equal 3, 8, and the blue line is factor OB or position factor B. The factor is 9, 6. Based on the rotational factor pattern loop, OA plus AB plus BO equals 0. Remember, factor BO equal minus factor OB. So AB equal B minus A. Two-dimensional factor. One way to represent a two-dimensional factor is with factor components. A factor in two dimensions is read as xy axis. For example, a factor with an x component of 5 and y component is 7. X component is red and y component is blue. Now we have factor. Yes, we have a green line factor. 5, 7. 5 is x component and 7 is y component. Very clear. Students, we go to representation of two-dimensional factor. A factor consists of x and y components. Look at the diagram. We have factor. The green color is OA, factor OA. The representation of factor O to A is AX and AY. And the magnitude of factor OA is square root of AX squared plus AY squared. On the diagram, we have factor 5, 7. So the magnitude of OA is root of 5 squared and 7 squared. 8.60. Three-dimensional factor. One way to represent a three-dimensional factor is with vector components. A factor in three dimension is x, y, z axis, or d3 or r cube factor. Look at the diagram. X component to the front, y component right and left, and z component up and down. For example, a factor OA is -2, 4, and 3. So an x component is -2, y component is 4, and z component is 3. Very clear, right? So the started at the origin would end at coordinates -2, 4, and 3. The representation of three-dimensional vector consists of x, y, z components. Representation of vector O to A is ax, ay, az. The magnitude is square root of ax squared plus ay squared and az squared. For example, draw and find magnitude vector below OA. Vector OA is 3, 4, 7. Okay, look at the diagram, three dimension. For the first, we have to construct vector x and y components. Okay, we got 3 steps and 4 steps, and the resultant of x, y is 5. Look at the step 1. The resultant is root of 25. We got 5. The next step is to combine the resultant of xy vector to z vector. We got step 2. The blue vector OA, the resultant of x, y, and z is 8.60. Very clear, right? Operation on vectors. Let there are two vectors. Vector u is x1 and y1, and vector v is x2, y2. Okay, I make it different color. For addition factors, addition factor is continuation factor, means the last factor will be continued to the next factor. So u plus v equal x1 plus x2 and y1 plus y2. Subtraction factor, actually the subtraction factor has the same process to addition factor, but only giving minus to the addition operation. Note for you, factor minus b is the same as traveling backwards down the factor b. So u minus v is x1 minus x2, y1 minus y2. The third is colored by factor k. K times u is ku. Okay, students, how to draw factors? The first is triangle method. Triangle method, draw the next factor after the previous factor done as continuation factor. You have to remember and listen. The triangle method is continuation factor. Okay, the first operation of addition factor, a plus b is 212. The purple factor is 74 and continue to factor b minus 58. And then we have to make a new factor from the start point to end point, the red factor. And the subtracting factor is a minus b is 12 minus 4. Okay? Factor minus b is the same as traveling backward down the factor b or inverse factor. Look at the green factor. Very clear, right? Go! How to draw factors by doing parallelogram method. Parallelogram method is draw both factors at the same point. Draw both factors at the same point as starting point and copy both factors to construct parallelogram. Okay, addition factors for a plus b by using parallelogram method. A plus b by using operations is 212. Look at the diagram. We just copy the green and purple factors to construct parallelogram. We got the red factors. And the subtracting factors a minus b. By doing the operation, we got 12 minus 4. Remember, factor minus b is the same as traveling backward down the factor b. Look at the diagram of subtracting factors. Factor a, factor b, as inverse vector b. Okay, we copy the parallelogram. We got any vector direct one. Okay, students, we go to tips and trick. I want to share you tips and trick. How to solve vector. 1. Redraw the vector diagram. Listen, you have to redraw the vector diagram. 2. Draw an outer loop or rotational vector as a help of direction out of available diagram. 3. Find all vectors that have the same direction. You have to start from this point. Yes, start from the same direction. Vectors. And number 4 is follow the direction of vector based on the point 3 above in the question. If the direction of the question is AB, just follow AB, not BA. Okay, students, go to the example 1. Look at the diagram. OAB is triangle, OA is vector position A, and OB is vector position B. Question: find vector AB in terms of A and B. Solution: look at the triangle and the purple loop as a help of direction. Start from vector those have the same direction is OA and AB. So OA plus AB equal OB. Clear? So AB is B minus A. To answer question B, remember the position vector AP equal vector P minus A, PB, B minus P. So AP to PB equal 3 to 1. By using the algebra, you got 1 times P minus A equal 3 times B minus P. And P is A plus 3B over 4. Very clear. Example 2. Look at the diagram. OAYB is quadrilateral. Vector OA is position vector 3A. OB is 6B. Find AB in terms A and B. Look at the triangle and the purple loops as a help of direction. Vectors that have the same direction is OA and AB. So OA plus AB equal OB. So AB equals 6B minus 3A. Very clear, right? To answer question B, remember the position vector AX is X minus A, vector XB is B minus X. So AX to XB equal 1 to 2 by using the algebra. So 2 times X minus A equal 3 times B minus X. So X is 2A plus 3B equal 5. Remember, OS 3A and OB is 6B. So you got OX 6A plus 18B over 3. Multiplication vector. Scalar multiplication or inner product or dot product. The scalar product of vector U and V is a scalar defined to be U times V or U dot V equal U1 V1 plus U2 V2 plus U3 V3. The product is scalar. Remember, the product is scalar. For example, I have vector U 3, 0, minus 2 and vector V 7, minus 1 and 6. By dot product U dot V, I got 9. Very clear, right? The cosine rule in Euclidean geometry. Based on the diagram OA, AB, and BO. So vector AB equal B minus A covers by angle theta. So U minus V, the magnitude square, equal magnitude U square plus magnitude V square minus 2 magnitude U magnitude V cosine theta. Otherwise, U plus V magnitude square equal U square plus V square plus 2 UV cosine theta in magnitude. And I have a new formula for this. A dot B equal magnitude A, magnitude B cosine theta. Okay, very clear, students, right? Students, now we go to vector projection. Projection of the vector EF on the x-axis L is a number equal to the value of the segment E1 F1 on the axis L, where points E1 and F1 are projection of points E and F on the axis L. Very clear, right? The projection is E1 F1. Okay. The vector projection of a vector A on a non-zero vector B is the orthogonal projection of vector A onto straight line parallel to vector B. The vector projection is W vector. The formula is A vector A dot vector B over magnitude B squared times vector B. And the scalar projection is the magnitude W vector is A dot B over magnitude B. And that's right. Okay, students. Several notes about vector. The first, listen to vectors A and B are orthogonal if they are perpendicular, i.e. an angle between them is 90 degrees. So A dot B equals 0. Second, two vectors A and B are orthogonal if their dot product is equal to 0. Third, vector parallel to one line or lying on one line are called a collinear vector. Remember, two vectors A and B are collinear if their axis and number n such that vector A equal n dot vector B. Okay, students, I think all the materials about vectors done. Hopefully everything's clear to you. If you think the matter is not clear yet, please rewatch the YouTube, study again, and try to understand to every single slide. Okay, student, I think to make sure everything's clear, you have to go to practice now. Thank you very much, and we go to the practice now. Thank you. Welcome again to my channel, DNA.12 Education. Today our topic in mathematics about factor. Yeah? Our topic is factor. Okay, students, I have one question. Let factor V equal I minus 2J plus 2K and factor U for I minus 3K. The question is, find the vector projection of V in the direction of U. B, the scalar projection of V in the direction of U. Okay, we try to answer. How to answer this question? Okay, students, we go to question A. Okay, the vector projection of V in the direction of U. Let this one the vector V, and here is the vector U. Okay. The product of the projection here. Okay. Let we name the vector projection V in the direction of U is W. Okay. Clear, students? Okay, now we go to the question A. The vector projection V in the direction of U. So the formula is vector projection equal V dot U over vector U, the magnitude of vector U square times vector U. Right? Okay. This is the formula of the vector projection. Right? Okay, now we are going to find V dot U. V dot U equal V is 1 minus 2, 2. 1 minus 2, 2. Right? Dot U is 4, 0 minus 3. How you know that? 4, 0 minus 3. The vector U is a complete vector. You have to complete the vector U. 4, I minus 0, J minus possible positive, that's okay. Plus or negative, that's possible. Then minus 3 vector K. Okay. So 4i minus 3k equal to 4i plus 0j minus 3k. Okay. So that's why the component of vector U is 4, 0, and minus 3. Okay. The product vector is 1 times 4 is 4, minus 2 times 0 is 0, 2 times minus 3 is minus 6. You got minus 2. Okay, so then we got minus 2. Okay, now we go to the magnitude U, vector U. The magnitude vector U is root of component of the square of the components respectively. So vector U, this one, 4, 0, minus 3. So the magnitude of vector U is 4 square plus 0 square plus minus 3 square, right? You got the magnitude vector U is root of 25. So you got 5. Okay? So that's clear? Okay, now we're going to continue to answer question A. So W equal V times vector U over magnitude of vector U square times vector U. Okay? Students, go. Next. Okay? V times U, you got minus 2 over magnitude U. Magnitude of U is 5 square times vector U. Vector U is 4, 0, minus 3. 4 minus 0 is this one, right? So this one, you can write here 4, 0, minus 3. Okay, so this one, you just copy, put here. 4, 0, minus 3, right? So we got minus 2 over 25, 4, 0, minus 3. Okay? 4, 0, minus 3. Okay, so then we can simplify the vector W. Will be minus 2 times 4 minus 8 over 25 I. Minus 2 over 25 times 0 means 0. plus 0g. Okay. Minus 2 over 25 times minus 3, you got 6 over 25. Okay. Or you can simplify minus 8 over 25 I plus 6 over 25 factor. Okay, so then, is it clear? Okay, this is the answer of question A. So that's, okay, we go to answer question B. Okay, so next we go to question B. The question B is the scalar projection of V in the direction of U. Okay, the scalar projection. Answer. The scalar projection. The scalar projection. The scalar projection means magnitude. Magnitude of projection. The scalar projection means the magnitude of projection. Okay? As I drew before, let's say this one is vector V and this one is vector U. You got the projection here, right? W vector, right? So the scalar projection is magnitude projection. Okay, so W, the magnitude, equal V dot vector U over magnitude of vector U. Okay, that's the formula of the scalar projection. V dot U over the magnitude of vector U, because the projection is V in the direction of U. Okay, next. Okay, we're going to find first V dot U. Okay, V dot U equal, this is the dot product, right? Okay, this one dot product. Okay, okay, now try to find the component of vector V. The component of vector V is 1 minus 2, 2. 1 minus 2, 2. And vector U, this one, 4i minus 3k, because the vector is not complete. So we have to complete the vector 4i plus 0j minus 3k. So the component is 4, 0 and minus 3, right? So V dot U is scalar. 1 times 4, 4, minus 2 times 0, 0, 2 times minus 3, minus 6. You got minus 2. Okay? V dot U, product vector. Dot product vector is minus 2. Now, try to find the magnitude vector U. Root of the square of the component of vector U. This one, right? Or this one, same. 4 square plus 0 square plus minus 3 square. You got root of 25. You got 5. Okay, the magnitude of vector U is 5. Now we are going to insert all the result, the before calculation to the formula. The scalar projection is vector V dot vector U over magnitude of vector U. Okay, this is the formula. Now we're going to insert all the calculation. Okay, we go to the scalar projection. The magnitude of the scalar projection is the magnitude of vector W equal vector V times vector U over the magnitude of the vector U. V dot U, we got minus 2. The magnitude of vector u is 5. So the scalar projection of v in the direction of u is -2/5. Clear, students? Thank you very much. Okay, students, we go to the next question about vector. Yeah, let vector u is ABC, vector v is BA3, u dot v is magnitude u square, and then magnitude of u minus p square is equal 5. Find the value of c cubed plus 2c plus 2. Find the possible value of c cubed plus 2c plus 2. So you have to find the possible value of c cubed plus 2c plus 2. Okay, students, we go to the solution. Students, we got any information based on the question. The first is this one. U dot v equal magnitude of u square. U dot v equal magnitude vector u square. Okay, u dot v, a, b, c dot p, a, 3 equal magnitude u, a square plus b square plus c square root square, right? Okay, go. Dot product AB plus AB plus 3C, okay, equal A square plus B square plus C square. Okay, students? So, all these items move to the right side. Okay, all these items move to the right side. Make it 0. So, A square plus B square plus C square minus AB minus AB minus 3C equal 0. Alright, so you can simplify. A square plus B square plus C square minus 2AB minus 3C equal 0. Then the first. Okay, next, the second. Okay, students, we continue the solution of this question. The last we got a square plus b square plus c square minus 2ab minus 3c equals 0. Okay, just give it. Okay. Go to the second information. The second information is u minus vector v equal u, this one, ABC minus vector v, BA3. Right? We got A minus B, C minus A, and C minus 3. Right? Okay. Now the information is the magnitude u minus p square is 5. Okay. Okay, students, continue to this statement. U minus p magnitude square is 5. Right? This one. A minus b square plus b minus a square plus c minus 3 square. This one, right? In root, but square. equal 5. Okay, so root and square cancel, right? Okay, a minus b square plus b minus a and a minus b same. So we change a minus b square, this one, right? Yeah. Okay. A minus b equal to b minus a square. Get it right? Here we go. Plus c minus 3 square equal 5. Good. Next one. So 2a minus b square, right? 2 plus c minus 3 square equal 5. Next, 2a square minus 2ab plus b square plus c square minus 6c plus 9 equal 5. Okay. Okay, students, we have the equation, the last equation from this one, we got this one, right? From u dot p equal magnitude u square, we got this one. A square plus b square plus c square minus 2ab minus 3c equals 0, right? So we can simplify this one, okay, this one, adjust to this one. We can adjust this equation to this equation. How to adjust the last equation to the previous equation, right? Okay. I think you agree with me. Okay. 2a square minus 2ab, sorry, 4ab plus 2b square plus 1, right? Simplify. 2c square minus c square. Do you agree? C square minus 2c square minus c square. You got c square, right? Okay? Okay. Why change c square to c square minus c square? To adjust this equation to the previous equation. Okay? So how? The rest minus 6c plus 9 equal 5. Great. Next. So 2a square minus 4ab plus 2b square plus 2c square. Okay, I change the color, make it clear. 2c square. And then minus 6c. And then minus c square. You write here minus c square, right? And the rest plus 9 equal 5. Clear? So, distribution. Okay, we put 2 out of the bracket. A square minus 2ab plus b square plus c square minus 3c, close the bracket, minus c square plus 9 equals 5. Clear? Okay. So we can write 2a square plus b square plus c square minus 2ab minus 3c. Okay. minus c squared plus 9 equals 0. A squared plus b squared plus c squared minus 2ab minus 3c equals 0. So all these items equal 0. Here, 2 times 0, 0, right? Okay, so sorry, this one is fine. So 2 times 0, 0, and then minus c squared plus 9, okay, and then equal 5. So minus c squared equals minus 4, right? Okay, I mean, the blue one, blue color, right? So cancel, right? So you got c equal plus minus 2, right? You got two options, positive 2 and negative 2. So here, okay, next, c equal plus minus 2. So means c is positive 2 or c equal minus 2. There are two options. Okay, for c equal to 2 cubed plus 2 times 2 plus 2. 8 plus 4, 12 equal 14. The first. The second. C equal minus 2. Minus 2 cubed plus 2 times minus 2 plus 2. Right? Minus 8 minus 4 minus 12 plus 2 minus 12 minus 10, right? Okay? So you have to answer 14 and minus 10. Clear? You understand? So we have to answer even 14 or minus 10. That's the possible value of c cubed plus 2c plus 2. Thank you. Okay, students, we go to the next question. Okay, I think this is the last sample for you. Let magnitude factor A is 8, magnitude factor B is 4, magnitude A minus B is 6 root of 3. Find the magnitude of A plus 2B. Okay, you got a formula to solve these questions. Please watch my YouTube, dna.12education. Okay, I already explained all the material about factor. Today, I just try to help you how to solve this question, right? Okay, come on, students. Sorry. Okay, students, we try to answer this question. How to solve this question? The first, you have to expand this information. Okay, magnitude A minus B equals 6 root of 3. Okay, students, magnitude A minus B equals 6 root of 3. Okay. Students, you know this formula, yeah? A minus B square equal A square plus b square minus 2 magnitude A magnitude B cosine theta, right? So 6 root of 3 square, okay, equal 8 square B 4 square minus 2 times 8 times 4 cosine theta, right? 180 equal 64 plus 16 minus 64 cosine theta, right? 180 equal 18, right? Minus 64 cosine theta. By using the algebra, cosine theta is minus 7 over 16. Okay? Minus 7 over 16, right? Next student. The question is this one. Magnitude A plus 2B equals something, right? So, magnitude A plus 2B equal root of, right? A square plus 2B square plus 2 magnitude A magnitude 2B cosine theta, right? By doing the square, you got A plus 2B square equal magnitude A square magnitude 2B square plus 2 magnitude A magnitude B cosine theta. Next, A plus 2B square equal A square, A square plus 2B. B is 4, right? So what about 2B? A square. Clear? B is 4, so 2B is 8. Clear? Next, plus 2 times 8. Sorry, here. So this 2B. Because 2B, right? 2B. A plus 2B square, A square plus 2B square plus 2 times A times 2B. 2 times A times 2B. Okay? Sorry. So 2 times A is 8. Okay? A is 8. Times 2B. 2B is 8. 8. Cosine theta. How many cosine theta? Minus 7 over 16. Right? So A plus 2B square is 64. 64 plus 2 times 8 times 8. This one, I think you can cancel this one, right? Then minus 56. So A plus 2B square equal 72. So A plus 2B equal root of 62. So A plus 2B equal 6 root of 2. Okay, students? Is it clear to you? Thank you very much.
From John Paul School, and I will start my 7th grade this year. I've joined QPC course since January 2020 with Mr. Jasper as my course tutor. Mr. Jasper did not only teach me the proper techniques of both maths and mathematica, but he teach me how to learn independently and how to stick into a problem to find ways of solving it. The course materials were good and it's based on my school curriculum. And the mentor approaching is also good. During the pandemic of COVID-19, we studied via the internet and it's also good. And I think Mr. Jasper is very good and it's a solid course. I learned a lot. Thanks, sir.
Hai, nama saya Cassius Nathanael. Saya adalah seorang siswa kelas 6 SD Penabur Harapan Indah Bekasi. Les di bimbel QPC sangat menyenangkan karena konsepnya fun learning. Cara mengajarnya pun asik dan tidak membosankan. Selama les di bimbel QPC, saya menjadi lebih mudah untuk mengerjakan soal-soal matematika. Karena di sini kita akan diberikan rumus-rumus jitu yang mudah dipelajari. Oke? Salam.
Halo, salam pelajar. Nama saya Pascual Clayton. Saya siswa Kolese Canisius angkatan 21. Saya di sini untuk memberi testimoni saya mengenai proses belajar saya di QPC selama masa karantina lockdown ini. Pertama, jelas belajarnya jadi lebih susah karena harus belajar online. Namun, saya berterima kasih mempunyai QPC untuk membimbing saya melewati perjalanan belajar online saya. Saya sama sekali belum familiar dengan proses belajar online. Saya sangat perlu bimbingan dan saya berterima kasih akan adanya QPC di situ untuk membimbing saya. Nilai saya pun akhirnya berhasil kekejar. Nilai saya yang 60 menjadi nilai 80 dan nilai saya yang 80 menjadi nilai 90. Itu adalah mata pelajaran IPA tuh. Jadi selama proses belajar online ini akhirnya kekejar juga nilai saya. Itu in part sangat besar karena bimbingan Sir Jasper dan QPC. Setiap malam kami belajar bersama untuk mempersiapkan diri untuk esok pagi belajar online. Jadi nilainya aman selama belajar online ini di QPC. Semuanya aman dan bahkan lebih meningkat kalau di kasus saya. Sekian dari saya, terima kasih. Salam pelajar.